My name is Levente Kurusa. I'm not sure if the microphone is fine. Perfect, right? So I work for Red Hat as a software engineering intern in Brno. I mostly work on virtualization stuff now. Before that, I worked on kernel, especially Linux kernel. And yeah, that's pretty much about it. So the topic I wanted to discuss today is how the Fedora kernel is different, or is it not different? We're going to answer that question by the end of the talk. The main focus of this talk will be the configuration options, and in order to not be bored, I also added a section about extra patches that the Fedora kernel, the Levente kernel, and the other kernels have in their own kernel tree. Yes. So I guess that everybody is already bored of the Fedora themed talks. So I actually thought about putting something new into the show. So I used something, I don't know, well, the screen resolution is screwed up. But
it's okay on this one.
Honest. Okay, so this is where this one, look at that one, it's probably better. Okay, so I wanted to show the topics, but in a more serious fashion. So maybe I can switch back off for a photo if you want. So yeah. So back in a more serious track, I'm going to start off with an introduction first about what kernels are we going to discuss, what this will not be about, and if it's actually worth it. We're going to cover extra patches into the distributions. Well, not all, obviously, because some distributions decided to take a lot of patches, so we're just going to cover the big ones, the big patch sets. And then after that, we're going to take a look at the configuration options, like what are they doing to the IO scheduler, their process scheduler. The other talk is basically about this. So let's go on a quick introduction of disclaiming first. So I wanted to talk about that this will not make any distribution better, right? So these are so minimal changes that it's interesting to talk about, but it will not make it different from any other distribution, because in the end it's all Linux, all free software. No, really, it will not make it better. Yeah, it's just going to be an overview, so I will not list everything, because first that would be too boring, and it would make no sense, because there's so much stuff, like, you know, you can include a lot of, I don't know, hard disk drivers or SCSI drivers, wherever you wish, but those are out of point, and they don't really make any sense to include it. You know? So okay, this is basically the same slide, but in another. So we're now going to talk about diff. So I'm just now going to show you output of the diff tool. Basically, that's the tool what I used for the configurations. And this is still not a list of all the differences, because still that would be very, very boring and useless. So it's still not a way to better and who's better, because I talked about that later. So the distributions that we're going to cover today is obviously the first one is Fedora. And we're going to cover OpenSUSE, and Ubuntu, and Arch Linux, the basic configuration from the Linux package. So we are now going to talk about Concoli plus, I guess, batch set, and I guess they also packaged real-time kernel, which we don't, I guess. We don't? Sorry. We don't package the real-time kernel in Fedora. Yeah.
Oh, yeah. No, there's been someone who does it off and on,
but it's not supported.
It's not in Fedora.
Yeah, but Arch Linux does package it, probably from an AUR, so you don't want to use real-time kernels on desktop anyway. So the target users, because I guess this is going to be important for the upcoming slides, so which distribution, what kind of target they have and what they want to accomplish. So Arch Linux is obviously not for beginners. It's mostly for developers and people who like to think with their stuff. So those guys who enjoy spending countless and countless hours on getting their servers working, pretty much will enjoy Arch Linux. Ubuntu, as I don't know, it's very strange now because they seldom serve as the desktop operating system, but as we later on see, it's mostly a server kernel. And yes, so they had probably transitioned to their server stuff. I guess they are using one kernel for the desktop and server, which actually makes sense, but not in that configuration. Fedora is users who like bleeding edge, but not as bleeding edge as Arch Linux, but a little more stable. And then comes OpenSUSE, which is what I call safely bleeding, because they will not crash so often, but they still like to crash, right? Okay, so that was the quick introduction, and we'll cover the extra patches that various distributions patch in their vanilla kernel source tree. So yeah, most of the kernels in distributions do not often just use the vanilla kernel. So Arch Linux, probably this one stays closest to upstream. They don't really have any extra package in their Linux kernel, because in the package of Linux, because obviously Arch Linux has a lot of different packages for kernels. As I previously mentioned, the CodeOS kernel and the RT kernel for the two instances. So they used to carry this patch, which added the BSS section to the PE-COF headers, if I was used. Although this patch was recently applied to upstream, as far as I know. So I just put it into parentheses because it's no longer relevant, but it's still something that they had carried for a long time. Yeah, this is another one that they filter out most of the messages from the DMAS, right? So they set the minimal print case, the printf equivalent in the kernel space to a value which I guess is word or something. So it's not info as in most distributions. So what Fedora, well, Fedora carries this in extra patches, is what Josh Boyer said in his last talk. It's ACPI is nice word here. So we carry a lot of scripts for various environments and devices to make them work, because I had a laptop once that was unable to boot due to some ACPI bugs. So I know by heart what problems ACPI can cause, and they do. We have, as far as I know, we have a sysrq for disabling secret boot if it's enabled, which is sysrq is the key which, as far as I know, is no longer relevant. At least I don't have it on my ThinkPad, but this sysrq is used to dump stack traces of kernel, to crash the kernel, and to power off the machine, and for a lot of other stuff, obviously. This was some kind of, it was under the break key, I guess, and it was used for debugging as well it is, and it's quite useful to have, and fun to crash it. If it's called the magic sysrq key, yeah, I know, right? So we have a lot of DRM fixes, which is Direct Rendering Manager, which is your video card. So we have for i950, I guess, and for the Nouveau NVIDIA driver as well, we have a lot from what I've seen. And now we're going to click over to OpenSUSE, which carries mostly not fixes, but a lot of new features. Most likely the rich ACL, which is a rich set of extra ACLs. I guess most of the people are familiar with ACLs, at least from CBS or something. So ACLs basically allow you to set permissions for the users of the operating system. So maybe not everyone will be able to write to this file. I'm sure you are familiar with ACLs in theory. So this rich ACL has been only in SUSE kernel recently, and they have only implemented it for X4, which is the newest generation of extended file system. And they carry overlay FS, which Josh already mentioned. What it effectively does is it combines two file systems. It has an upper and a lower file system, I guess that's the word for it. And it crashes often, but in theory what it should do is, so yeah, you could basically have two file systems in one folder if you'd like. And it's quite useful to have, as you already see. It has a dozen of SAM patches, and for your own app hardware stuff, which is an LSM, which I'm going to talk about later. Later security module, which is added into 3.6, I guess, or whatever. Okay, so you might be actually wondering where Ubuntu is. Well, Ubuntu, I tried very hard to get their source tree, but I don't know, they were hiding it from me or something. It's ridiculous. So I just decided it wasn't too interesting anyway, because they are now leaking Fedora. So yeah, we're going to move to the next part, configurations. So what differences are there in configurations with respect to their benefits or disadvantages, depending on what they do and for who they do it. LSM is probably the biggest difference. Fedora is, as far as everyone knows, is solid SE Linux camp, which is a mandatory access control by the NSA. It can be trusted. Then there is also AppArmor available, which is mostly used by SUSE and Ubuntu. Tomoyo and SMAC are two lessly known, I would say, because I never heard some people use it. But Tomoyo is, and again, an MAC, while AppArmor and SMAC are path-based, so they do it in another way, which is not the point of this talk. But yeah, SMAC tries to be very simple, and it is simple. I used it actually and try it out. It's quite more simple than SE Linux, which some people just like to set in force 0, but that's a useful comment if you run into problems with SE Linux. So memory allocator, which I found to be very interesting, that some people, namely we're going to see what it does, it hands out memory chunks. The slab allocators, what I'm going to talk about. There are two main choices here, which is slab, which is very old, and is the original one, and slab, which is a newer version, and is a lot better to use nowadays in most workloads. However, Fedora uses slab obviously, but OpenSUSE uses slab, which is, I have no reason, I don't know why they're using slab. It's kind of strange because slab is generally be deprecated and people like to use slab for everything. But yeah, these are all the others, all the distributions are from these four I looked at use slab, but OpenSUSE is the only exception. And yeah, slab has been here for a longer time, but slab is generally the better option for everything. It uses a different structure to maintain objects, because what slab allocator is, in theory, is that once you're done with an allocation, the slab allocator will, you free the allocation, the slab allocator will remember where this size of object was, and then when later on you request the same size, then it can reuse the memory allocation without converting the body allocator, which is what the other part of the memory management. Schedulers. Linux ships the following schedulers. Which obviously, these are not kernel configurations, but these can be switched in runtime. FIFO, which is first in, first out. We have that. We have a batch scheduler, I guess, from Ingo Molnar. And this is very useful if you have a few, but very CPU-intensive tasks running. It can really achieve a better performance than the CFS that we currently have. We have the idle, which is exactly the opposite. So if you have like one task, which mostly idles, so I don't know, for example, whatever server which just handles requests every few hours, then you better off switching to the sketch idle because it will use a lot less power. The sketch idle, which is mediated by POSIX, and is currently the completely fair scheduler designed as well by Ingo. It has replaced the O1, well, as in big O notation, scheduler a few years ago, and which was the first fair scheduler, but this was completely fair. The main difference being that it uses a structure called the red-black tree in order to find out who the next task would be to schedule to. And there's the RR scheduler, which is probably the same as FIFO, but it uses a round-robin algorithm, which you mostly want to stick with sketch idle. If you're not doing something very special like idling most of the time, if you are an IRC, you can switch to sketch idle. That's what you do, you're idling an IRC. However, if you do something very CPU intensive, like compiling thousands, or it's not possible, but a few hundred kernels at a time, you might want to switch to batch scheduler because that will make it a bit faster. Actually, if it will be noticeable, I'd make that. So we have a scheduler frequency, which pretty much means that there is a chip and the chipset that interrupts the processor in a constant amount of time. So that's what signals the CPU to decrease the remaining time slice of a given process, and then finally schedule the processor to another task. So OpenSUSE uses config AC 1000, which means that every second, every CPU will be, and every CPU is important here, will be interrupted 1,000 times, which means that tests which might happen 1,000 times a second, but it's not like, that's not the way it goes about it, in a nutshell. On the other hand, Levente uses Hertz 250, which is a lot less number. So tasks will be given a lot more time to run, and generally here it depends on workload. So if you want a desktop if you are going to use in a desktop and you need high user interactivity, so you want to respond quickly to clicks and stuff, you're better off with a higher number, otherwise it might stall. But there's another part to this, which I'm going to cover in the next slide. Fedora obviously uses 1,000, so we still interrupt tasks 1,000 times. But it's actually the number of scheduler the timer ticks between a second is actually the number of CPUs times this value, because every CPU needs to be interrupted to switch tasks. Linux strangely uses 300, which is kind of strange because I guess Linux is mostly for desktop and people who want to blow up stuff. So this is the second. This is the only value between 250 and 1,000, as far as I know. So it's probably they wanted a balance, and this is the only one that the kernel had allowed them. Kernel preemption is what if a user wants to do something with the hardware, it interrupts itself and then traps into kernel space. And generally, kernel was not able to be preempted due to various reasons. Preemption means that it switches tasks. Not exactly, but that's how it goes. So we had something like the big kernel lock for a long, long time before we had Spinlux. So kernel preemption effectively solved a lot of problems. Like the kernel was not able to be. So when a task was in kernel space, we did not allow that task from being scheduled away. So it was there in kernel space until it gave up and now returned to user space, in which situation it was scheduled to give other processes time. It was a very stuttery process. Yes. We have 3 options, which is preempt known is the first one, which is original behavior, which means that we do not preempt in kernel space like we did. And actually this is good if you have only a few tasks running, and this will actually make it a bit faster. But if you have a lot of tasks running, and you're quite CPU intensive as well, and this will make all the other processes which are not in kernel space stall, and it can cause hiccups. Voluntary, which means that the kernel is not fully preemptible, but there are points in the kernel where the kernel voluntarily gives up and allows scheduling. These are mostly before Spinlux and after Spinlux, and some other places, obviously. And we have the config preempt, which means that in every location, excluding critical sections, which are between Spinlock and Spinunlock, the kernel can be preempted. So it gives. This is the one you want to select if you want to use a desktop configuration, because it will have the lowest amount of latency. Yes, that's the correct word. But voluntary will have a nice balance between them, but most of the time everybody uses preempt, as we're going to see it. OpenSUSE uses full kernel preemption. Fedora uses voluntary, which I'm not sure why is that, but we still say that if you can, it might not be that safe, but if we have Fedora, I guess we're also looking at a desktop mostly, so why now with Fedora next we're not just looking at the desktop. So I guess voluntary might be a nice middle road between the 2 solutions. We now know preemption and full preemption. Linux uses full preemption as well, while OpenSUSE uses voluntary again. Yes, Ubuntu. CPU frac, which is CPU frac governor, which controls the CPU's frequency, and it's so simple. I'm just going to leave this out. So we have a few governors, which is performance, which tries to drive the CPU crazy by having the highest frequency possible, even higher than that sometimes. And we have a user space, which allows the user space to control it if they want it. We have power save, which effectively means that it saves power by running low when it is not necessary to run high. And we have the conservative CPU frequency as well, which tries to conserve space as well. So the default governor for CPU frequency is the on-demand in Fedora, which means that as much demand as there is, the CPU frequency will scale with that. OpenSUSE uses the same. Ubuntu uses performance, which I found strange, but after reading up my Ubuntu boxes in the scripts, I found out that they switch back to on-demand after they did the boot process. So I guess their point for that is just to make the boot process a bit faster, because on-demand requires a bit of a spin-up, and that might make slow, and obviously our Linux uses on-demand as well. Now, I wanted to talk about why configuration sucks in the kernel right now. There really is just one sane answer to most of the configuration options in the kernel. And I wanted to close this with a quote from somebody. I'm not sure if anybody will guess who he is. I'll leave this to the reading for you. So if you can guess who he was, who said this. I'd be very happy if somebody knew it. Or just have a guess at it. It's not hard, not simple.
Gandhi.
No, not Gandhi, yes.
Linus, probably, but...
Yes. Obviously, it's particularly good at it. Like, who talks like this on camera? You can find, like...
It's a little mild, isn't it surprising?
Yeah, it can get worse than this. So yeah, there's more armless bug, which continues forever, and it's just never stopping. Yes, I guess that's, yeah, Linus Torvalds. So, to give proper credit to his post in the HTML, which is single worst. I guess I don't find the configuration the single worst part. The LKML is the single worst part, which is the mailing list. I recently had a talk about that, and it was a good talk. And it was long talk about why LKML sucks and why people don't like to post an LKML but rather post to the subsystem lists instead. So I guess that's what I wanted. I hope nobody is going to be injured after I finish, because it's the last talk in this today. And yeah, have a wonderful luck. If you have any questions, feel free to ask it. There are my mail addresses as well if you want to write me something. I don't have spam filters, sadly. So you can find me on Google+, and Twitter is the one that I maintain the most. If you have any questions, then ask them if you want, or... Yes?
Would you know if there are any plans to include the GRSec patches into the Fedora kernel?
Oh, I'm not a person to answer that, but I guess Josh should answer it for us.
Which patches?
GRSec.
The GR, security patches.
Oh. So, wait, hang on. So part of my job as a team lead is to handle questions from people within Red Hat that want to do things that my team would freak out about. So Justin says no. There's not any interest necessarily in integrating them into the Fedora kernel that would properly go to the rest of Fedora users. But there are people interested in providing a Coper or something like that with that patch set applied. There was a group that is looking at a study to see, okay, of all those patches and all the bugs that we have for security issues over the past year, how many would those patches fix, right, or prevent in some way? And so there's people looking at it, but at the moment there's no plans to add them to Fedora directly. So there is interest, there's just no plans. So
I see if the new playground would
yeah,
solve
I mean,
it.
I should have added that to my slide, but yeah, I mean that's something that it may or may not work itself into Playground. It might be its own special Coper build, because there are people that are very interested both from inside Red Hat and from the community as well. There's a really long history with that patch set, and there's lots of reasons why it's not upstream, because the two communities don't necessarily work well together, but that doesn't necessarily mean they're bad, right? So that's the question.
All right. So maybe you can find it in a playground, in time or something like that. Yes?
Okay, on the slide where you compared the H settings,
The what settings?
HZ.
Oh, the frequency. Yes?
So
Do you maybe go back?
I'm missing the comparison between those kernels, whether there are chickless or not, because this is really what matters.
Well, I wanted to include tickless, but there were not so many differences between.
But that means that these numbers are basically useless.
Not really. If you have workload, then they are not. If the CPU is ill, then tickless has sense because it will not interrupt the processor while it's idle. But since most of the distributions now include config HC full, which is the one you're talking about, I don't know, a year ago they might not have included it, I'm not sure. But it was because it was not mature enough. But now it's working and everybody has compiled it in, so it's not something I thought it would be worthwhile. It isn't really a difference, which is what my talk was about.
But the numbers aren't useless.
Yes.
Even with the tapeless kernel, that number will also determine how many time slices for your tasks.
Yeah, sure.
So if you have a workload, a bunch of stuff trying to run at once, the ones that are running at 1,000 are going to swap them out faster.
Yep.
Yeah, that's true. Yeah.
But they are, all the kernels today are tapeless.
Yeah. So, I guess. Any questions? You can mail me on wherever mail address you find. Oh man, where? So, no, it's just okay. I'll just leave it as it is. I just LibreOffice, yeah. Okay. So thank you for your attention. Have a wonderful flock.